Okay, it's been now almost a year since I created this channel. And now, after more than 5 million views, of which I don't really know how they happened, I think I owe you an explanation of who I am and what I'm doing here. Now, maybe the first thing that you need to know about me is that I am personally not a big fan of announcing things before they actually are something. So I'm not going to talk about a specific timeline for the future of the MPS, but I will share a lot about how all of this happened. There have been a lot of questions about where my technical interest comes from, but honestly I feel silly telling you a lot of stories about my childhood, so I will try to keep it short. I grew up on what you could call a farm. My parents had horses, so there was always lots of work and lots of things to fix. So my brother and I always built a lot of stuff. Tons of things that I really enjoyed. Tree houses that connected over 50 meters of trees, automatically deploying huge nets to catch other children, a dam that dried out the entire next village for weeks. The list is endless. But there were also many other things that were no fun at all. Countless repairs to electric fences and leaky water pipes, built decades ago by people who had so much work that they weren't interested in reliability, but simply in something that was good enough. And when you are standing outside in freezing temperatures for hours repairing water pipes that are completely covered in mud and manure, only to have to go back 2 weeks later because it starts again, I think it's only human to get an interest in reliability. And later at school I loved physics. And after I finished school in 2016, I did a gap year because I was only 17 years old and I didn't want to go straight to university. During this time I built a lot of different things. A vending machine, a chaotic storage system for the workshop we had at home, my first CNC machine, and I bought a first 3D printer. As a result, it was just logical for me to study engineering. At least that's what I thought at the time. I started to study industrial engineering with a focus on electrical engineering in 2017. I spent 5 years at university, and even though on paper that was exactly what I was interested in, I hated every second of it. So I started to distract myself with tons of side projects while studying. And one of these side projects was, and I don't really know how this happened, but at one point I was running a company with a friend that offered engineering services. The concept of that company was that students would offer engineering services in mechanical, electrical, and civil engineering. We were about 30 students. Customers varied, mostly medium to large companies. I think I went to maybe 15 industrial trade shows that year and tried to acquire new customers there. In retrospect, I think at least this had the positive effect that I visited a lot of companies. We did that for almost 2 years, but it quickly became clear that it just wasn't my company. We were just employed to run the business. And I think there were some fundamental problems in the business model and also in how the project teams were structured. That itself led to a lot of quality issues that made it impossible for us to continue without feeling terrible. So we both left the company. I'm usually not the type of guy to have regrets, but with this period, I honestly wish it would have been a bit shorter. I mean, sure, I would love to tell you all about how great it all was, but it just wasn't. So much of it was like straight from a Gilbert cartoon. So, did I really had to experience it so painfully, spend so much time? Maybe. During my time at the engineering service provider, university somehow ran on the side, and I only wrote a few exams. But now that I was no longer working at the same time, I finally wanted to finish university. It had already been 3 years and I just wanted to get it over with. But then COVID happened, and during the first lockdown, I wanted to buy a new monitor. So I went to Amazon and searched for one. But instead, I happened to find someone offering VESA adapters that were very poorly designed. If you want to mount a monitor to a wall or an arm, you usually take off the original stand and attach the screen to 4 standardized mounting points. Almost every monitor has these mounting points, but some do not. Together with a friend of mine who was my roommate at the time, we both decided to sell an adapter. It was more of a joke, and we thought if we sell 5 of them a month, it would be nice. If you offer things through Amazon, there are many different options, but basically you can separate it into you ship the stuff yourself, or you choose fulfillment by Amazon, where you send a whole bunch of products to an Amazon warehouse and they handle the shipping. This option is very expensive, and there are lots of hidden costs that make a margin calculation almost impossible. But for us who wanted to continue studying and had a high margin product, we thought it would make sense. So we packed, I think, like 25 adapters and sent them to Amazon. We thought they would last for at least 2 to 3 months. At least. But it was the time of the absolute home office boom. And I think they were sold out in like 6 hours. So we made more. And after a few weeks, we had 10 different adapters and wall mounts for vacuum cleaners, monitors, and so on. Over the next 6 months, we sold a couple of thousand of them. Included with these parts were sets of fasteners that we counted by hand. And that gets very boring very quickly. So we thought about buying a machine. The machines that are available for this, that are used traditionally, are vibratory bowl feeders. They are very loud. I mean, it's basically a big vibrating drum with lots of metal parts inside. To feed and count the parts, they need to vibrate at a specific frequency. And this means that they can only hold a certain amount of mass, so you would have to add storage bunkers and so on. It gets all very expensive very quickly. So I wanted to build something that was cheaper, more compact and quiet. And also something that was parametric, or at least could be used universally for different parts. And also we had a few ideas for packaging. So I started to build a parametric feeder for fasteners. But then something happened. You see, the adapters we sold on Amazon were just stupid parts. I mean, yes, they were well designed and getting some money was nice too, but I didn't care about them. I did not care about stupid wall mounts, and my roommate felt the same way. So we stopped it. However, I kept on working on the MPS. Throughout all of this, I was always trying to get through my studies at the same time, which never worked well. I could probably talk for hours about why I think that was the case and how I think universities could be improved, but I'll try to keep it short. I studied at the Technical University of Darmstadt. I think it's fair to say that this is one of the toughest, if not the toughest, university for engineering in Germany. And it is also a university with quite a lot of history. The electrical engineering degree was literally invented there. It was the first faculty in the world to offer it in 1883. Many things like the microphone and the device all of you are holding in your hand right now were invented there. What follows is my very personal opinion, so take that with a grain of salt. The university is very aware of its reputation and it does everything to maintain it, which is a good thing. The problem starts with how they do it. The right way would be to offer excellent education and pair this with extremely difficult exams, which would lead to very well educated students. Or, and I think that's what's happening, you simply have difficult exams and low quality of teaching. This means that as a student there, you need an extremely high tolerance for frustration and have to teach yourself most of the material. And that filters very efficiently. 9 out of 10 students there will tell you that they don't enjoy their studies. But the thing is, that's not good education. It's efficient filtering, and that is worth something. But, many of my friends never had technical interest, and they ended up just going into consulting. I think that relatively speaking, the German education system is still pretty good. But nobody should care or be interested in relativity, and I still think it's bad. Now, I never was a good student, and at some point, a little over a year ago, I just felt like my thinking was getting worse because of it. And I didn't want to spend another second there. So I decided to drop out after 5 years before I graduated. So I'm not an engineer. I would like to add one last thing. It wasn't an easy decision to drop out at all, and I think I'd be an idiot if it had been easy. A lot of people think it's cool to drop out. I don't. I would much rather have a degree and be doing what I'm doing now, but it didn't work out that way, and that's okay for me. But I don't think dropping out is a feature. To be perfectly clear, the vast majority of people I know who have dropped out are either too lazy or too stupid. And right now I am in the same group as them. Like everybody else, I claim to have dropped out for the right reasons. And only time will tell if this is right. MPS means modular production system. It's supposed to be a whole pool of inexpensive automation modules that are easy to integrate and can be set up in software, not just feeders. I think there are so many machines that could be built much differently, with a modern system architecture, with a different philosophy. In manufacturing, nobody ever asks how can we generally solve a problem. Everybody just builds their own special machine for their own special application. Do you know why robots are used that much even though they are so expensive? In many applications, it's not because you need the degrees of freedom, but because they are so universal and can be set up only in software. Like this, you don't have to play so many rounds of ping pong with your supplier beforehand. I think with real parametric design, you can do that for other machines as well. No more ping pong. Ping pong is an expensive sport. I know that manufacturing is not seen as very attractive, but it is damn important. Everything around you was manufactured. How it looks, how you use it, is defined by how it's made. Now the feeder won't change anything about manufacturing. It's just a stupid machine. But I hope that this way of building machines might inspire others to do the same, and not only make automation accessible, but also pave the way for something that I call digital hardware. But it is still a bit too early to talk about this in detail. I personally see problems in an open hardware business model. I think people underestimate how many open source projects end up as an unused and half-finished GitHub repository. Don't get me wrong, I really like the idea of open source. I just personally don't see it as the right business model in hardware. I think especially because these are B2B products with a supporting business case behind them, it's much better to pay a very competitive price for something that works rather than getting something for free that doesn't work. People are going to save a lot of money because of these machines. And I think it's only fair that they then support the development of future modules. I'm very limited by the tools that are available to me. A working business model would provide the resources for R&D, and I think in the end that makes a lot more of a difference than just having a few files online. I didn't really do anything special. They simply contacted or reached out to me. Most of them found one of the videos. For the mechanical part, I use mainly Autodesk software. Mostly Fusion 360 and sometimes Inventor, but Fusion has gotten much better over the last year with big assemblies, so mostly Fusion. I think this was the second most asked question. The question refers to the fact that the pickup wheel and the feeder works with magnetism to transport the fasteners. This works great with steel screws, but stainless steel is not magnetic and therefore the wheel cannot feed them. Or can it? Most of the non-rusting steels in use are chromium nickel steels. These steels are austenitic and therefore cannot be magnetized. However, if stainless undergoes a certain degree of cold plastic deformation, the microstructure changes, at least in the deformed areas. If you have a bent stainless steel pipe, then it happens often that the bent part of the pipe is magnetic and the rest isn't. Luckily, screws are taken through a lot in the manufacturing process, and therefore many stainless steel screws are magnetizable. By the way, it's not that stainless steel is an exclusively great material. It is softer and has virtually no spring effect. But to answer the question in a nutshell, most stainless steel screws, at least that I use, can be picked up by a magnet. There are other parts, such as wall anchors, where this will not work, and for this we will need a new module that works differently. I never enjoyed tinkering with printers, and I think if you want to use them to sell something, it should be a tool. Back then we used Prusa Mark III's, but if I were to do it again now, then I would probably use Bamboo's, maybe P1P's. But if you really plan to do that, my general advice would be, unless your part is very small, use printing up to a certain quantity, maybe up to 500 pieces or so, so enough that you can assume the part will sell and then switch to injection molding. You will have to redesign the part and it will be a pain, but at least you will learn something, and for a simple part, injection molding is not that expensive. Otherwise, you will just spend too much time running a print farm, and the only people who really make money from print farms are the printer and filament manufacturers. If for some reason you still need to have a print farm for longer, then try to time all the prints so that they run in 12-hour shifts. That way you only have to go there twice a day to restart them all, and all at the same time, and you might at least have a chance to concentrate on something else. It doesn't matter if a printer does nothing for 2 hours. If you don't have enough capacity, buy another printer. Don't check the printers on your app, don't go there to restart a failed print. You should only enter the room twice a day, otherwise you can't concentrate on anything else. On the other hand, I expect the upcoming Bamboo printer to have automatic print removal. So maybe wait for that. I don't have any inside secret information. It's just my personal guess. It would make a lot of sense to offer that, and based on the people I know at Bamboo, they will do what makes sense. Normally I only use the date of the last save change. Sometimes I also include the name of the assembly, and if someone wants to write a Fusion 360 plugin that automatically stamps the timecode from the last save at a pre-selected location, that would be so cool. That's a really cool question. Satisfactory is a game where you build a factory and have to automate more and more items to reach the next level. Now, I personally never was that much of a gamer, and I had never heard of the game before someone commented it under one of the first videos. I tried it a few weeks ago, and it's really pretty cool. Also, there are some crazy similarities to MPS. For example, I use extrusion frames on most of the machines because they are very parametric and they remind me a lot of the modular frames in Satisfactory. What about your drawing board in the background? Do you use it? It is an old drawing board from the 70s. It's made by an old German West Berlin company, and I bought it secondhand from a very friendly 92-year-old retired engineer. He showed me how to use it, and that was really helpful. The thing has what feels like 20 adjustment points for planarity, orthogonality, and so on. He has been designing on it for basically its whole professional life. For example, one of the first designs for these vertical windmills was made by him on this very drawing board. Also, I just called him last week, and he really likes the fact that all of you enjoy the drawing table so much. I also find it fascinating how using it feels so similar to the Space Mouse. Do I use it? Not really. In theory, you can even put it completely horizontal and use it sitting down. But unfortunately, I just don't have the space because this is really big. And I'm just way too fast in CAD to really draw on it. I sometimes use it a bit for documentation. Documentation is important, but you can sink endless amounts of time into it. So I have a very minimalistic approach. And for this, it works great. Okay, I think this was really the most frequently asked question. The small arm is needed so that the bolt head can pass through the wiper. It always opens just at the right time. So the real question is, what are the bolt heads for? The screws are not used to fix anything. Mainly they steer the parts, which significantly increases the feeding rate. Depending on the fastener, this can almost triple the feeding rate. It is really not as easy as it looks at first glance to separate parts with a magnet. I try to do most of the designing in my head before I start, so I think a lot about it. After that, I might do 1 or 2 tests, but most of the time I go straight into CAD. In CAD, I then try to push through the whole thing until it's finished. A lot of people print or pre-prototype something in between, but I'm not a fan of that because when you start to print, you stop thinking about it. After I have finished the whole thing in CAD, then I print or machine or order all of the parts at once. I think it's important to aim for a works first try. And it's totally okay if it doesn't, but if you are not even trying, you're not thinking about it properly. I have a lot of theories that I think are important for good design and for a good design process. But that's going to be a separate video because that would be way too extensive and beyond the scope of this video. However, I would like to at least briefly discuss 3 aspects that I think are very important and probably unconventional. They make it easier to better understand the videos and myself. The first is what I call permanent pessimism. Others might call it German. For this, I need to explain a little more. Me and many others are very enthusiastic, or let's call it passionate, about automation or technology and systems engineering. It is a common misconception that this itself leads to good and reliable solutions. On the contrary, enthusiastic people in engineering tend to build much worse and unreliable systems than those who simply do their job based on experience. Of course, someone without passion could never build something really great, but still the vast majority of enthusiastic tech people is bad at tech. And I think that's why it's important to use the, let's call it positive potential that you have in your enthusiasm. You should ask yourself the hard questions. Thinking it won't work because is the best thing you can do. You see, I have more than enough enthusiasm for building that nothing will ever stop me from designing systems. So I have the luxury to be very critical and still remaining positive. Be as pessimistic and critical as you can, while still staying enthusiastic. In the moment in which you think you have done enough, you will stop building good systems. This is always struggling with getting something done and carries the great danger of being stuck in the iterative hamster wheel forever. That's why you should aim for as few iterations as possible as soon as the overall system is built. Once you're trapped in an iterative infinitum, it's almost impossible to get out. I think that everything great is on a very, very fine line. And this is another one of those balancing acts between constantly critical and calling a version done. One of the things you hear engineers say all the time is it's a trade-off. And even in college you learn that everything is a trade-off. It is probably the most engineering thing to say. Let's say you are developing a phone. On the one hand, you want to give it a very big battery, and this means it will have a lot of battery life. On the other hand, you also want a device that is still portable and light. You can't have both at the same time, so you make a trade-off by sacrificing some battery size for better portability. Initially, this concept helps you a lot to think because it gives you more structure. You start to ask yourself what is really important about the thing, and that leads to better thinking and better designs. The problem is that's a fundamentally wrong way to build great stuff. You can use it to excuse absolutely anything. The car I designed breaks down every couple of 100 miles. Well, it's a trade-off, otherwise it would be too expensive to make. We know that this is not true, but you can talk yourself into it. You can argue every bad design decision that way. Our brain is lazy. It loves the opportunities to stop thinking about something. In the long run, things tend to converge so that you get both. You will get a cell phone with a big battery that is still small. I mean, yes, in the end it is a trade-off in the sense that you will reach physical limits at some point, but it's not a good way to think. When they tell you at university that everything is a trade-off, it's like they are trying to force you into the local maxima. And in my opinion, it is a local maxima that most engineers will never leave in their lifetime. So I would say, if you don't think in trade-offs, start doing it. It will help you. And if you have been doing it for a while, have the confidence to leave it. You can want everything at the same time, and if you have enough structure in your thinking, it will make you much better at design. Something that might surprise some of you is that I'm not a huge fan of 3D printing. I mean, I like it and I use it a lot, but the main reason is that it's cheap and I don't have money. These are videos about what can be done with 3D printing, but they are also videos about what should not be done with 3D printing. Everyone always says how much creativity additive processes enable, but I think that's a fundamental misunderstanding. I would like to tell you a short story. In the 5 years I spent at university, there was a single electrical engineering department that actually took an interest in the students. This department offered a practical project every year. This is a project in which 5 teams of students have to compete against each other and build something. The topic is always different. Sometimes it was a diving robot, sometimes a robotic ripper, and in the year I did it, we had to build a small line-following car. As in all years, most of the participants were electrical engineers, and most of them had very little experience with CAD modeling. But it was one of the first years where 3D printing was allowed. The previous classes had to go down to the workshop to have something milled. But we had the Prusa for each team. So what you would expect is that the results were better. The quality of the prototypes was higher than in previous years. But what happened was the exact opposite. They got much worse. The only manufacturing process that people were still using was 3D printing. And everyone was designing, and before it even was half done, it was already printed. I don't think most of my classmates realized that the results we were getting were very bad. I think everyone had fun, but no one thought long enough about what we were actually building. The previous years without 3D printers were forced to think more, and that led to much better results. If I show you this picture and you imagine yourself standing in this forest at one of the edges of the canyon, why do you suddenly want to build a bridge? It is not because you came there with the goal to build a bridge. It's because people want this to come up with that. Constraints are the foundation for creativity, and an environment rich in constraints and supplies is the most creative. Minecraft in creative mode on a single plane of bedrock is no fun. That's what 3D printing can be. Be aware of the constraints, look for them. This is also the real reason why people hate support material. It's not because it's a waste of material or because it's ugly. You hate it because you love the limitations of having to design it without unsupported overhangs. We need the thought about printing orientation to even come up with a part. I have now given a few examples of manufacturing-based constraints, but they only get you past the first bump. So what are medium-level constraints that enhance creativity? The two most obvious points are probably cost and laws of physics. They are not only good for creative thinking, they are essential. If you ask me, that's also the main reason why, for example, SpaceX builds better rockets. It's because they try to build them cheaply. Having to reduce the cost of a build is a very powerful constraint enabling creativity. It is not that all the other space companies have stupid engineers. Yes, talent makes a difference, but system architecture makes a bigger one. Cost is a very good and easy to quantify constraint. But besides the mentioned constraints of manufacturing and the constraints given by the environment, there are others. Formula One, where cost is irrelevant, is one of the very few examples where regulations can be efficient constraints. One thing I've been thinking about for a long time is if we want to build the best machine, what would be the optimal constraint? One that results in a reliable system with a good architecture. This means that we need to understand how complexity works and what it is that makes something work well. I am convinced that these constraints exist. They are the starting point of what experienced engineers call instinct when you ask them how they designed the basic system layout. And every instinct is just an algorithmic and therefore deterministic process that we just don't understand. I think there are rules for that. We should stop guessing machines and start building them. Invent instead of discover. I do have a few ideas about this, and one of them is complexity shifting, but that's way too much for this video. I've always had the most passion for the very edge cases of complexity. But I think I have to, and somehow I want to, work my way through it. Partly because very complex work correlates with needing a lot of money to do it, and partly because it feels right to earn it. I have a very strong sense of what feels right and what does not. And if that feeling is correct, then I don't see a problem with doing it. I never wanted it to be easy, and if my feeling turns out to be wrong, then none of the really complex stuff I'd like to work on would have ever worked. Anyway, you asked about me, and this video was about me. I hope that it's not too much. The next videos will be a bit more relaxed again. I love and enjoy working on the MPS, and I think for the tools that are available to us, there is some cool stuff coming.